Hello everyone. Today we'll be looking through few problems with respect to this amplitude modulated wave. The first one is a 400 watt carrier is modulated to a depth of 75%. Calculate the total power in modulated wave. First we'll see what's been given. Given PC, which is equals to 400 watts, and depth of modulation is, that is m is equals to 75%, which is nothing but 0.75. We are asked to calculate what is PT. So we know that PT is equals to PC into 1 plus m square divided by 2. Just substitute. It's a direct substitution problem. Substitute the values. PC is 400 into 1 plus what is m? M is nothing but 0.75 square divided by 2. So which is equals to 400 into, solve that, 1.281, which is equal to 512.5 watts. So this is the total power of the AM wave. Coming to the next problem. A broadcast radio transmitter radiates 10 kilowatts when the modulation percentage is 60. How much of this is carrier power? So here in this problem, they have given PT. PT is equals to 10 kilowatts. And M is also given as 60%, which is nothing but 0.6. And we are asked to calculate what is PC, that is the carrier power. So we know that PC is equals to PT divided by 1 plus m square by 2, which is nothing but 10 kilowatts. 1 plus, which reduces to 8.47 kilowatts. This is again the direct substitution. Power of a carrier signal is equals to 8.47 kilowatts. The next one is the current calculation. So here let IC be the unmodulated current and IT be the modulated current of an AM transmitter, both being the RMS values, and where R is nothing but the resistance in which these currents flow. Then PT by PC is given by 1 plus m square by 2. We have already seen this formula. This power in terms of current and resistance can be given as I square T R, that is I square R, P is equals to I square R, then IC square R is equal to 1 plus m square by 2, where R gets cancelled. We get I square T by I square is equals to 1 plus m square by 2, which can be written as IT by IC is equal to root of 1 plus m square by 2, or IT is equal to IC into root of 1 plus m square by 2. Even this formula is very important, which can be used in solving the problems. The next problem. The antenna current of an AM transmitter is 8 amps when only carrier is sent, but it increases to 8.93 amps when the carrier is modulated by a single sine wave. Find the percentage of modulation. Determine the antenna current with the depth of modulation changes to 0.8. Here we can write down the given parameters as IC is equal to 8 amps. That is, they have given 8 amps when carrier is sent, which means that IC is equals to 8 amps. Then IT is nothing but, that is, it says that it is increased to 8.93 amps. That is 8.93 amps. And we are asked to find out what is the modulation index. As well as in the next part, they have asked to determine the antenna current. when the depth of modulation changes to 0.8. So that is IT, find out IT when m is equals to 0.8. We know the formula, IT by IC is equal to root of 1 plus m square by 2. Now we want to find out m, the depth of modulation. Therefore, this it can be rearranged as m square by 2 is equal to IT by IC whole square minus 1. Just rearranging, we're going to get m square is equal to 2 into IT by IC whole square minus 1, or we want to find out what is m. M is equals to root of 2 into IT by IC whole square minus 1. Now substitute the values that's been given over there. After substitution, we get m is equals to root of 2 into, what is IT? IT is 8.93. What is IC? IC is 8 whole square minus 1. On solving this, we'll be getting root of 2 into 1.116 square minus 1, which is equal to root of 0.492, which is equal to 0.701. That is m is equals to 0.70, or in terms of percentage, we can write this one as m is equals to 70%. Solving the first part. In the next part, we are asked to find out what is the total current when the modulation index is changed to 0.8. We already know that IT is equals to IC into root of 1 plus m square by 2, and now IC is equal to 8 into root of 1 plus, what is modulation index? It is 0.8 square divided by 2, which is equal to 8 into root of 1.82, which is equal to 9.19 amps. This is the total current that's been asked. The next topic is modulation by several sine waves. So we know that when only one sine wave is involved in modulation, then only one depth of modulation we are going to consider, that is m. But when there are different sine waves, then total modulation index have to be considered. Now let us check the first method, that is V1, V2, V3 and so on are the simultaneous modulating voltages. Then the total voltage is given as root of V1 square plus V2 square plus V3 square and so on. Now dividing both the sides by Vc, Vc is nothing but the carrier voltage, Vt divided by Vc is equal to root of V1 square plus V2 square plus V3 square and so on, because we don't know how many sine waves are there, and whole divided by Vc. Now taking this Vc inside, so V1 square divided by Vc square plus V2 square divided by Vc square, V3 square, so on, and wherein this ratio of voltages is being given as Vt by Vc is given as Mt, that is total modulation index, is equal to root of M1 square plus M2 square, M3 square, so on. These M1, M2, M3 are different modulation index of different sine waves that are involved in modulation. And the second method is to find the total power of an AM wave. We know that Pt is equals to Pc into 1 plus m square by 2. That can be written as, take this Pc inside, Pc plus Pc m square divided by 2. So what is this? This is nothing but the power of a carrier signal, and this is nothing but an power of an sideband. That is PSB is equal to Pc into m square divided by 2. Now if several sine waves are involved, then the carrier power will be unaffected, but whereas the sideband power will be the combination of n number of sine waves that are being present. Therefore, power of a sideband, that is the total power of a sideband, is equal to PSB1, that is sideband 1, and PSB2, that is sideband 2, and power of sideband 3 and so on. So what is this? This is nothing but total sideband. This can be rewritten as PC into MT square divided by 2, which is equals to, so again substitute here, PSB1 is written as PC M1 square, that is first sine wave, this is the first modulation index, divided by 2, plus this is PC M2 square divided by 2 and so on. So here PC and 2 will get cancelled. Therefore, this equation reduces to MT square is equals to M1 square plus M2 square plus M3 square, or MT is equals to root of M1 square plus M2 square plus M3 square. Now we'll look through this problem. A certain transmitter radiates 9 kilowatts with the carrier unmodulated and 10.125 kilowatts when the carrier is sinusoidally modulated. Calculate the modulation index. If another sine wave corresponding to 40% modulation is transmitted simultaneously, determine the total radiated power. So first we are supposed to find out modulation index of that first wave, that is given PT is equal to 10.125 kilowatts and PC is equal to 9 kilowatts. For this power, we are going to find out what is the modulation index. Then if another sine wave, after finding out this modulation index, if another sine wave corresponding to 40% modulation is transmitted, then second modulation index, this is M1, let us take this one as M1 and this as M2. They have given M2 is equal to 40%, in the sense 0.4. Find the total radiated power. So finally the total radiated power is been asked. So we know that PT by PC is equal to 1 plus M square by 2. Again this can be rewritten as M square by 2 is equal to PT by PC minus 1. So this is equals to, substitute the values of PT and PC, 10.125 divided by 9 minus 1, which reduces to 1.125 minus 1, that is M square by 2 is equal to 0.125. Therefore now M square is equals to 0.125 into 2, which is equals to 0.25. Therefore M is equals to root of 0.25, which is equals to 0.5. That is, now we have found out what is the modulation index. The first problem is solved. For the second part, the total modulation index will be, that is MT is equals to, we know that root of M1 square plus M2 square, where M1 is equals to 0.5 and M2 is equals to 0.4. Just substitute the values. Root of 0.5 square plus 0.4 square, which is equal to root of 0.25 plus 0.16, which is equals to root of 0.41, wherein we'll be obtaining 0.64. Now substitute this total modulation index in the equation. PT is equals to PC into 1 plus MT. Now it is MT square divided by 2, which is equal to, what is PC? PC is 9. 9 into 1 plus 0.64 square divided by 2, which is equal to 9 into 1 plus 0.205, which is equals to 4.84 kilowatts. So we have found out the total power wherein two sine waves are being involved. Thank you.